This is question number 9 on the Unit 3 practice test. It says we have a container. It is a cone, and water is being evaporated so that the depth of this is changing at a constant rate of negative 0.3 centimeters per hour. So this height is decreasing by 0.3 centimeters every hour. It gives us the volume of the cone, and it also tells us that the proportion relating the radius and the height remains constant. So notice the height of the entire container is 10, and the radius, it gives us the diameter is 10, so the radius is 5. So the radius is 5 centimeters when the height is 10 centimeters. So notice the height is equal to twice the radius. That proportion is going to be the same through the entire problem. The height is always going to be equal to twice the radius. So part A wants to know what is the volume in the container when the height is 5. So if I go to my equation here, V equals 1/3 pi r squared times height. Height is 5, and if the height is 5, that tells us that the radius is 5/2, 2.5. So we should be able to get the volume there. 1/3 times pi times 2.5 squared times 5. So our volume is 32 point, remember we always round to 3 decimals, 725. Units here would be cubic centimeters. Part B asks us to find the rate of change of the volume of water in the container with respect to time when the height is 5. Make sure we include units. So we know the volume is equal to 1/3 pi r squared h. And we also know that h is equal to 2r. It's easiest if we plug this in now before we take any derivatives. So let's go ahead. We are going to replace h with 2r. So r squared times r, so I've got r cubed, 2 times 1/3 pi, so we have 2/3 pi r cubed. So now we can take the derivative, and I don't have to use the product rule here because 2/3 pi is just a number. So dv dt is equal to, if I move my 3 out front, I get 2 pi r squared times dr dt. Question wants the rate of change of the volume. So I'm looking for dv dt. When the height is 5, we just said when the height is 5, my radius is 2.5. So we can plug in 2.5 for r. We don't know dr dt, and it's not given in the problem here. They gave us dh dt. They gave us the rate at which h is changing. If I take the derivative of this, I get dh dt is equal to 2 times dr dt. And dh dt is negative 0.3. So dr dt, if I divide both sides by 2, is negative 0.15. dr dt is negative 0.15. And now we have everything we need to find dv dt. Two pi times 2.5 squared times negative 0.15. Negative 5.890. Units of volume would be cubic centimeters, and units of time in this problem is hours.